Okay, this video is all about PMCC, and it's something that we touched on in the first video, but now this is looking at the other two questions on PMCC. But also touch on other topics as well, like standard deviation here. So standard deviation, the way we work that out is we do the sum of x squared over n minus sum of x over n, because this here, sum of x over n, is the mean, and we're going to square that. So if we substitute those values in, that's going to be 985.88 divided by 8, because n is 8 in this case, minus 86.8 over 8 squared, and we square root that. So we're all into your calculator into three significant figures, you should get 2.35. So that's the first 3 marks, and not too bad. As long as you've done a few of those and you know how to do this standard deviation, that's reasonably straightforward and marked. Now, the next one's only worth 1 mark, so in theory you've only got a minute or a minute and I think 12 seconds to do that. So we've got to show, because Tanya's also using the standard deviation, but this is of a different set of data. This is y hours per week. So we've got to work out what SYY is. So in previous videos, I had a look at how to find SYY. Now, SYY is the, sorry, it's not square root at all. What we're talking about is sum of y squared minus sum of y squared over n. Now, we've got the standard deviation here, so we've got to find some sort of link. So the standard deviation of y, that would be the sum of y squared over n minus sum of y over n squared. You can see it kind of looks similar. So what we're going to do is, if we square both sides, so standard deviation squared, we get sum of y squared over n minus, now what I'm going to do for this here is I'm going to write it as sum of y squared over n and times by 1 over n. Oops, 1 over n, not 1 over 2. Now, if we times both things by n, what we end up getting is n lots of the standard deviation squared, and that equals sum of y squared minus sum of y squared over n, which is SYY, and it's this link. And it's not the easiest thing in the world to do, but if you've seen this, it means quite an odd way of doing it, but if you have seen this, then it's dead quick. So if you know the link between the standard deviation and SYY, or SXY, so SXX, all you need to do is you square the standard deviation and then you times it by n. So what we've got here is we've got a standard deviation, so we're going to do 9.461 squared, and then we're going to times that by 8. And if we do that, 9.461 squared times by 8, we get 716.084168, which to 3 significant figures, as always, is 716. So that one is just 1 mark, but it's knowing the link between the standard deviation and SYY, or SXX. Again, what you need to do is you need to square it. If you square the standard deviation and then times it by your value of n, you get SYY. So what we could have done here, and just double check your answer, you could square or if you squared your standard deviation and times it by n, that's going to be SXX. Okay, so the next thing, we've got to find SXY. So, SXY is sum of xy minus the sum of x times the sum of y all over n. So we're told that the sum of xy is going to be 4,900.5 minus we do the sum of x, which is 86.8. The sum of y, which we don't know, but if we know that the average of y is 58 and there's 8 weeks, the way you work out the average of y is the sum of y divided by n, which in this case is 8. So if we times 58 by 8, we get 464. We're going to divide that all by 8, and that's going to give us SXY. So doing that, (4,900.5) minus that gives us minus 133.9. So that's our value of SXY, minus 133.9. And then we've got to work out what the PMCC is. Now, just like before, in previous videos, PMCC R equals SXY over the square root of SXX times by SYY. So R equals minus 133.9 over SXX we don't know yet, but SYY which worked out to be 716. But just like before, to go from this thing here to the standard deviation, we have to square it and times it by n. So if we've got the standard deviation here, or we just work out standard deviation this way actually. So SXX equals sum of x squared minus sum of x squared over n. So if we do that, we get 44.1. So if we substitute all that in, so minus 133.9 over the square root of, and then just make sure you do this bit first, you end up getting, you get minus 0.754. If we round it properly, it's 75353. But the mark scheme allows us minus 0.753 or minus 0.754. But minus 0.754 is what you get if you use all the rounded values. So now, during Tanya's week-long holiday in Seapon, there are 14 millimeters of rain and 70 hours of sunshine. So, state, given a reason, what the effect of adding this information to the above data would be on the value of the PMCC. So, it's only worth 2 marks, so we don't need to do any calculations for this question. But we know that 14 millimeters of rain, that's the x value, so we know 86.8 divided by 8, so the average is 10.85. So Tanya had more than average rain, and we know that the average sunshine is 58, so she had more than the average of sunshine. So what she's saying here, she's got more rain and more sunshine. Now our value of R showed a reasonably strong negative correlation, which means the more of one thing, the more of the x value, so the more of the rainfall, the less of the sunshine. But what we've seen is that more of the sun, more of the rain, and more of the sunshine. So this goes against this thing here. But what we've got to be careful of is that it actually lessens the correlation, which means it would make the correlation less strong, therefore the value of R would get closer to 0 as it goes against our relationship, and our relationship being negative correlation. Negative correlation. That's what you need to do. And that's how you do this question. So let's have a look at the 2015 version of this question. So we've got an estate agent record the price per square metre. It's important to read these questions quite carefully. So price per square metre for 7 two-bedroomed houses. He then uses coding. So our value of Q has been made by P, take away A, and then divided by B, where A and B are positive constants. So if you have a look at all of these here, we've gone from 1840 down to 4.0, 1848 down to 4.8, 1830 down to 3.0. Notice that the last two digits are the same as these two digits here. So they've got rid of the first two digits, so they've taken off 1800. So it's going to be P take away 1800, and that would leave us with 40. How do we get from 40 down to 4? We divide by 10. How do you get from 48 down to 4.8? You divide by 10. So therefore, your value of A equals 1,800, and the value of B equals 10. The agent also summarised the distance of each house from the train station. The results summarised below. So SDD, SQQ, SDQ. Calculate the PMCC between D and Q. So what we usually know is R equals SXY over SXX times by SYY. Just make sure we square root the bottom. So here they've replaced X and Y with D and Q. So what we're going to do is R equals minus 2.17 over the square root of 1.02 times by 8.22. And if we put that into our calculator, and that's minus 0.749 to 3 significant figures, as always. Now, this has been coded, but this one here, write down the value of the PMCC coefficient between D and P. Now, coding has no effect whatsoever, so therefore it's going to be exactly the same, minus 0.749. And that's the key thing there. Coding does not affect PMCC. The estate agent records the price and size of 2 additional 2-bedroom houses, H and J. Suggest which house is more likely to be closer to the train station. Justify your answer. So what we've got here is, notice that this is price per square metre. So we've got to work out the prices per square metre. That's the first thing we're going to do. So if we do H, that's going to be 156,400 divided by 85. And that gives us £1,840 per square metre. If we do 172,900 divided by 95, we get £1,820. So again, we know we've got negative correlation, which means that the bigger this is, the smaller this is. So therefore, the bigger this is, the smaller Q is, and that's going to be the distance. So therefore, H is going to be closer to the train station because it's got the bigger price per square metre. Therefore, it's going to be closer due to the negative correlation. That's what you need to write down. So you're going to get 1 mark at least for doing 1840 and 1820. Then I'm going to say that H will be closer as the bigger the value of P, which is price per square metre, the smaller the D, which is distance to train station. due to negative correlation. And again, and if you've done that, then that's going to be enough to get the marks for this question. So well done if you're able to follow that.